Good evening, ladies and gentlemen, and welcome to the webinar Improving Your Workflow using Abaqus FEA software by Faculty of Engineering and Built Environment of Mahsan University. My name is Amin Khabawi, and I am a civil engineering degree student at Mahsa University, and I will be serving as your moderator today. So, today we will be hearing a presentation from Mr. Muhammad Zulkhairi bin Muhammad Basro. Mr. Muhammad Zulkhairi, he has more than 5 years of research experience in civil and field major in materials and structural engineering. The research he conducted was more focused on finite element analysis using Abaqus FEA or FEA software, green concrete materials development, and related civil engineering structural problems. He obtained both of his bachelor and master degree in civil engineering at University of Tun Hussein on Malaysia. Currently, he is working as a lecturer in Faculty of Engineering and Built Environment at Mahsa University. Without further ado, I would like to welcome Mr. Muhammad Zulkhairi, who will be speaking to us on improving your workflow using ABS FEA or FEA software. All right, Mr. Mohammed Zulkhairi, the floor is yours.
Thank you, Mr. Moderator, Mr. Muhammad Amin. So, Assalamualaikum and very good evening. So, for today webinar, I will share my experience on how to improve your workflow using Abaqus Finite Element Analysis software. So, as the introduction, there's a lot of knowledge and lot of reference that you can get to solving your analytical issue or analytical problem. So in this webinar, I will share my experience on how this finite element analysis can improve or can solve your analysis rather than referring from any books or any literature or anything else. So, okay, in example of the field of engineering, okay, there's a lot of calculation involving, which is the analysis for the beam, including the deflection, the shape, beam moment, and anything and else. And also until we want to conduct the stress analysis on the flat surface of the plate. So, however, these several problems usually comes with assumption and some limitation on the calculation. So it will become the burden that sometimes the user of the on the engineering fields had been faced, which is there's a problem sometimes about the geometrical shapes, the boundary condition, the material and the loading and etc. So in this webinar, we will utilizing the finite element analysis in solving the problem. So as been in the slide, okay, finite element is a powerful numerical technique, okay, which is use computational power, which is your computational or your NDPC or your private PC, to calculate or solving the approximate solution to this type of problem. So there's a lot of various problems have exist in the world of engineering. So for this software, we will the working is like the dividing the object into some complicated elements that I will explain to you through this webinar. And then it is very useful for solving the geometries, complicated geometries, the loadings, and the material properties. So for the example, like the beam, sometimes it can be made of concrete and sometimes it can be made from steel. So by using the software, it will be automatically solved for the user. Okay, and then the finite element analysis also is widely used in the geotechnical engineering, which is the analysis due to stress or material behavior. And then there's also the others branch in geotechnical engineering, which is slope stability analysis, soil consolidation, and so on. Okay, it same goes on to the transportation engineering also, which is we want to analyze the road or the tire on the surface of the road. So we can analyze the bridge, analyze the slab cracking of the pavement, and then simulate the mix of asphalt behavior and so on. Same also to the our main, not so main, is concrete technology, which is mostly on the building for civil engineering students or civil engineers need to analyze their design, need to optimize their design. So they also can use this finite element analysis software. So it is like the wide industries that commonly apply finite element application from the mechanical until the electromagnetic field. Also, we can apply it in the human body, which is more on the biomechanics or maybe in the uh, hospitality or whatever that requiring the simulation of certain case. So, how does finite element analysis work? So, this is most likely like our main objective for this webinar, which is how this finite element analysis, or we call it FEA, can solve your daily problem. Okay, let's start with the example. Okay, we have outdoor air conditioning unit bracket, so it will be supported by two brackets. So right now we want to analyze, or in the terms, we want to analyze the static stress that happen on the bracket. So as shown, as shown in the slide, okay, the goal of the static stress analysis is to calculate the stress, strains, and displacement that happen within the bracket. Okay, after the loading has been applied, same also with the others engineering or structuring features, whereas the loading has been applied. So normally we will use normal calculation to identify the displacement, the stress, and the strain happen at the bracket. So from the final element analysis, okay, after we conducting the computational work, we will get the values, stress, strain, and displacement, and then we can identify which location has the most critical uh, critical stress or critical strain or critical displacement. As being shown at the figure, okay, the red color show that the stress is very high, and then the strain also very high at the top surface, but and then this displacement also very high at the end of the bracket. So in solving most of engineering calculation, we will using the equilibrium concept. Okay, the equilibrium is defined as the state in which opposing force or influence are balanced. So for the example, you have the force from the x-axis and the force from the y-axis. So how you need to make it equilibrium is by balancing the force that come from the both of direction. Okay, in this finite element analysis, so we use the equilibrium concept, and then the concept is like the internal stress that develop within a body is to maintain the equilibrium over any volume of the body, which means that in the bracket, all the force are equilibrium. So in this concept, equilibrium, we will apply it into the finite element analysis concept. Okay, so the concept is, for the example, the concept is very simple. If we want to calculate the bending moment on the simple beam, okay, the concept is like when we manually calculated the normal single beam, we will get the bending moment and the shear force along the beam, and then eventually it will resulting the normal and shear stress of the beam. But that is for one dimension only. How about the two and three dimensional shape? So it will require a lot of calculation and then a lot of time. Also, sometimes the calculation will be errors. So they will involving the analysis to be incomplete, and sometimes the engineers also feel very hard to solve the problems. So by applying the finite element analysis software, okay, the actual body object or model that we have been designed, it will be splitting into the small elements. Okay, the small elements consist of these elements, and then it is connected by the nodes. Okay, the nodes is like the interconnected between the elements. So this process from splitting the small element from the body or the object is called discretization. So by dividing the total bodies or the total object into one small element, okay, and then it will be connected by nodes. Okay, the total elements and the total nodes that have been splitting in a body, we call it mesh, which is the group or which is the summation of the elements and total nodes in the body. Okay, actually, the elements consist of various shape. But in this webinar, it will be there will be another webinar that will explain more detail on the certain software. So on this webinar, I will just explain to you about the basics of the usage of the finite element analysis. So from here, we just can optimize, we just can calculate the static analysis from the finite elements calculation that has been conducted by the software. So discretization is useful because the equilibrium requirement is currently needs to be satisfied over the finite number of discrete elements instead of continuously over the entire body. So by using the discretization method, okay, the calculation will be simplified by the finite number of the elements, and then it will resulting the result as shown. Okay, and then there's also some values happen and on the surface. Okay, this is the example of the finite element analysis software in market nowadays. We usually Abaqus, SolidWorks, MATLAB, ANSYS, and so on. But certain software has come with different parameters or different requirement, which is such as like the types of their solving problem, and then their limitation, and then their price for sure, and then their license. And usually, there's also some free software package that offered for students or for the lecturers to teach or to conduct any class. So it will be useful for any, for me, the undergraduate students projects that involving the simulation. Okay, and then how can the finite element analysis helps the user? So I will divide it into two, which is the user and also some of the designer when they are working. Okay, for the user, it is easily applied to complex irregular shape objects. So let's say that the example with the bracket system. So there's a lot of irregular shape object, which is sometimes involving the three-dimensional objects, and sometimes there's involving a six to maybe more than 10 shape. So it is very compatible to apply for the finite element analysis. And then it can be applied to any objects with different type of material. Let's say that the material for the object is made from steel, and then the tire or anything else made with rubber. So it can be determined on the finite element analysis software, and then the element analysis software will conduct the calculation for you. And then for sure it is applicable to linear and non-linear problem. And then that's for the user. And how about the designer? The designer usually in what we call the automotive industries that they need to design something on the cars, or they need to design something on the aerospace system. So they need to optimize their design to fulfill the requirement that's set by them, which is they need to obtain the highest strength of the car bumper, but with the lighter material. So everything will be defined at the system. Okay, and then this final element analysis will help the designer and the user to solving the problem. So this is the advantage of any finite element analysis software, which is same also. It can handle complex geometry, can handle vibration, heat transfer, fluid, and also some movement of maybe like fluid, blood, or anything else with liquid. And there's also the other advantage. So, however, it comes also with the disadvantage, which is it is requiring specific numerical result, which is you need to identify what is the result that you need to obtain after you finish your simulation. So after that, after the simulation process, so of course you need to manually check also with this manual calculation as it's some one call the call terms what we call the convergence studies or the you need to validating your result. So it also same to validate your result with the reference from any reference. So it is also need a powerful computer, not so powerful, but sometimes usually it is requiring a lot of process, which is your processor need to run in a longer terms. So it will requiring you a lot of electricity bills and also generating lots of heat. So this needs some powerful computer and then reliable finite element software. And then it also you need to also uh, have any experience on conducting the software, and also maybe you can get some professional advisor to complete your final analysis. So that's all from the webinar. Thank you, and I will give it to you again to the moderator.
We have come to the end of the presentation. Thank you very much, Mr. Mohammed Zulkhairi. That was really, really a good enlightenment for all the students for addressing this interesting topic. And thank you for our audience for an active participation. Hopefully, the presentation was beneficial for everyone. On behalf of MASA, we would like to thank you for joining us today. Thank you for your time and patience. This end.
Thank you.